matching. Okay. So we've got a set of data, and they give us the mean, the median, and the standard deviation, and then they give us a bunch of histograms. For all of these, your mean and your median should be exactly the same. And then your mean and your median should be the same for each data set here, not like for all of them. So this one's a little bit different, it kind of sticks out. So what I do usually on this one, these ones can get a little bit tricky. I think you get multiple attempts on this one, but it can get frustrating. So let's say first identify the graph with the different, let's see, mean and median. So for us, that's the 65. So all of these are centered around 58, but data set number 2 has an average of 65 instead. So if we look through here and try to figure out which one we think has an average of 65, so here 65 would be maybe about right here. That doesn't look like it's the average. This one, 65 isn't even on the graph, so that one wouldn't be it. Here, 65 is right here. That could potentially be it. And here, 65 is over here. So that's not going to be it either. So C is the only one that really would make sense to have an average of 65. So for C, I'm going to say that's data 2. Instead of 50. Okay, so that kind of narrows it down a little bit. So now we've got 3 more to worry about. So now what I'm going to do is find the graph. So these are the other 3 are all going to be centered at the same thing. So they've got the same mean and the median. The only thing that's going to be different is how spread out they are. So now I'm going to find the graph with the smallest standard deviation, which should be fairly easy to find because you don't want to just look at the shape of the graph. You want to look at the units as well. So if you look at this one up here, A, it goes from about 33 up to 88. This one goes from 53 to 63. Don't worry about C because we're done with that. And then this one goes from 8 up to 118. So if you look at just the range, it's going to be this one. It only goes from 53 to 63. It has the smallest range. So it's going to be compacted. It's only in between these 10 numbers, whereas this one, the range is from 18 to 88. That's a range of 70. And then the last one has an even larger range, I think. 8 to 118, it's a range of 110. So this one here has the smallest range, so it's going to have the smallest standard deviation as well. So B is going to be 1 because it has the smallest standard deviation. This is going to be the same as the graph with the smallest range. All right. And then I'm going to do the same thing, but I'm going to find the graph with the largest standard deviation, which means the one with the largest range. So now I'm down to, what, A and B? So A has a range, goes from 18 to 88, so that range is 70. Down here it goes from, did we say 8, right? 8 to 118, so this one has a range of 110. All right, so since D has the larger range, it should have the larger standard deviation. So we've already done, 1 and 2, we've already placed those. So now we've got 3 and 4. 4 has the largest standard deviation. That should correspond to the largest range. So we'll put 4 here. And then the last one is going to be 3. So we'll put 3 right there. So with this one, just start by checking the mean and the median, finding the one that kind of doesn't belong, and then to figure out which one has the largest or the smallest standard deviation, just find the one that has the largest and smallest range, just looking at the units down here of the lower class limits. Okay. That's everything I wanted to do from there. So for 3.3, we're going to do basically just the mean and the standard deviation for group data. When we have group data, that just means it's going to be a frequency distribution. So the problem is if we have a frequency distribution, we don't know the actual